Today we're going to be learning about Bohr models. Bohr models are useful because they give us information about the atoms, such as their number of protons, neutrons, and electrons, without having to look at a periodic table. Let's start by looking at atom A. The P in the center of the atom stands for the number of protons. The N stands for the number of neutrons. In this example, P equals 1 means that there is 1 proton or 1 positive charge. N equals 0 means that there are 0 neutrons. In order to find the number of electrons on this atom, all you have to do is count the dots appearing in the electron cloud. In this case, there is only 1 electron, which matches the number of protons. So we know that this model was done correctly because you should always have the same number of electrons and protons. I've added the square for hydrogen so you can compare it to the atom A. If you notice, the P equals 1 is our number of protons and electrons. So here's our ape, which corresponds to the 1 found on the periodic table. Our neutrons is when we have to solve the man. So the mass is 1.008. We're going to round it to 1 though. So 1 minus 1 equals 0. So 0 neutrons. Now let's take a look at atom B. Atom B has 3 protons in the nucleus and 4 neutrons. So P equals 3, N equals 4. The number of electrons can be found by either looking at your protons or counting the electrons in the electron cloud. So this atom has 1, 2, 3 electrons found in the cloud. Notice how this atom has 2 rings or electron shells instead of 1. Whenever we have more than 2 electrons, the third electron is actually going to be moved into the outside ring of the atom. The first electron orbital can only hold 2 electrons, and then after that, the third has to move to the outside. The second ring can hold a maximum of 8, and if there's a third ring, that too can hold 8. Let's look now at atom D. Atom D says that there should be 11 protons, so therefore there should also be 11 electrons. Let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice how the first ring of electrons only has 2 electrons in it. After that, the next 8 go in the second ring. After 8 electrons, any additional electrons have to go into the third ring, which can also hold a maximum of 8. In order to determine which atom that you're looking at, you need to know the atomic number or the number of protons. The number of protons found in an atom is going to correspond to the number on the periodic table above the atom, which is the atomic number. The atomic number is going to be the identity of the atom. So each atom has a unique or different atomic number. So this atom has 11 protons, meaning sodium is going to be the only atom that has those 11 protons.